How's it going? Today we're going to look at 9.4. This is another type of transformation. It's called compositions of isometries. So let's first talk about what's an isometry, and it just means it's going to keep the same distance. So we have certain types of transformations that keep the same distance, and those are the ones that we've talked about so far. Translations, rotations, and reflections are all isometries. To say we're going to do a composition of an isometry means that we're going to do multiple transformations. So I'll do a reflection with another reflection, or in this case, you can see where so I talked about this, this, and this. We also have something we call a glide reflection. Well, that's two things happening. It's a translation, which we call a glide, and then a reflection. So when you do two different transformations, that's what we're doing today. Okay, so let's start with this. We have just a few types that we're going to do. One of them is going to be reflections across parallel lines. So what you have here is you're going to take this triangle and you're going to reflect it across L. It's going to land here. And let's look at our notation as we talk about this. This composition, it's a reflection over L first, followed by a reflection over M. So this is like reflection of M of the reflection of L. Okay, so flip it over L, get the A prime, B prime, C prime, reflect it over M. Now it's A double prime, B double prime, C double prime. That's our notation for that. Okay, the thing that's weird is that when you look at this right here, it's not really in the order in which you do it. Again, reflection of M of the reflection of L. So you really do this one first and then this one. Now if you look at this, take a look at the pre-image and your resulting image down here. Ultimately, after you've reflected that twice, can you see that this is really just a slide? The orientation of this one is the same as the blue one. It just was a translation. So if you reflect twice across parallel lines, you simply end up with a translation. Okay, so let's practice this once. Look up here to see, it says you're going to do reflection over M of the reflection over L. So start with the reflection over L, then do the reflection over M. Makes sense. I'm going to do T over L and then that over M. Got it? And then the question is, what's the distance of the resulting? Now in class we used an index card to kind of help us with our right angles, because if you just eyeball a right angle, it's usually not very accurate, and then if you try to construct your right angle, we're going to be here forever. So we kind of cheated. We're going to use the corner of an index card, and that's always going to create a right angle there, so that's going to help us make sure that when we drop and we make this a reflection, if you'll recall, this has to be like a straight shot, and then a straight shot. Again, it's got to be perpendicular. All right, so here's what we did in class. I've got this T. I'm going to reflect this over L. First thing I'm going to do is pick out some key parts of this T that I'm going to be translating, or I'm sorry, reflecting. I'm going to start with this end right here. I'm going to work with that, and then I'm going to work with this spot of the T, and then I'm going to work with this spot on the T. And I'm going to color code this first one. You probably don't have to color code because it's not near as messy as what our previous constructions are, like on rotations. It shouldn't be that bad. But here's what I'm going to do. I'm going to take my index card, and I'm going to bring it over here, and what I want to do is I want to line it up. All right, so line it up, sorry. I'm going to line this up so with my red dot, you can see, I'm going to create kind of this right angle with line L. Now, this first line, I actually already drew a perpendicular in there for you, but I'm going to show you how I did that perpendicular. I took my right angle and created that, lined it up nicely with L and with my red point there, and then I came over here and I said, all right, that needs to hit right here then. And then I came back and got my ruler and I drew this big long line through my two pink points, and that's where I got that line. Now I'm going to do that with all three key points. I've got it done with the pink one. Now let's do it with the green one. Now, you can see here, now I'm going to stretch my index card bigger, but yours shouldn't be that big of a deal to do that with. But you want to make sure that you kind of get that lined up so it lies right along the line L and also goes through your point. Mine's a little temperamental. Hopefully you can do better with your index card than what I'm doing here. But okay, so you're trying to line that up perfectly. Mine's not perfect. I'm just going to go with it here. And then I hit, okay, well then that's going to have to hit right there. And now I'm going to do the same thing with my blue dot. I'm going to scooch my index card up here and mark right where that would create a right angle. All right, once I have those marks, now what I'm going to do is get rid of my index card, and I'm going to get my ruler out. Now I'm going to freehand this because it takes me forever to do this digitally, but you can do this with your ruler pretty quickly. You're just going to take and draw a straight line through your key point that you have, through the mark that you made for your 90 degree. And then you're going to make that as long as you can. I'm sorry, mine's not perfect. Now these lines, if you do this right, should all be parallel. Then I'm going to make another one with my blue line. And there was supposed to be a blue mark there. It disappeared when I moved. It was attached to my index card. You can see it over here. Okay. All right, so I'm going to pretend it was right there. Get your lines marked in there. Okay, now what we're going to do is we're going to take our compass to measure how far these are supposed to go. So if this point here, this pink point, is this far away from my line, then I'm going to mark on my compass that far away and then put my point here and mark it on this side. I need to get a point over here that's the same distance away from the line. I'm going to do that with each one of my points. So I'm putting the point at A, seeing how long that is, copy that measurement over here. Do it with the green line. Put your point right here, measure how far that is, copy that distance over here. Do it again on the last one. Put your point right here, measure how far that is, copy that distance over here. Now I'm going to draw my T that has been reflected over L. And so the top of the T connects blue and green, so here's the top of my T, and then red. Okay, so mine's a little bit funny looking, sorry. I'm just freehanding it. Yours will look better. Now I will say that in class today, we had a little bit of trouble with dealing with our compass with such a tiny little distance. These are just so close together, it's hard to be accurate. So if you wanted to use a ruler and say, oh, this is like 6 millimeters, and then measure 6 millimeters, that'd be fine. I can see right here that this is too long. It really should have been here, and then my T would have looked better. I might fix that. But again, if you want to measure here, let's say this is, 1.5 centimeters, and then measure 1.5 centimeters this way. You can measure it if that's easier for you. I'm going to fix that. I'm going to pretend that this arc was a little bit shorter, which means my T would have gone more like to there-ish. See how I fixed that? Okay. All right. Now, let's do this all again. I've already got my lines. That part's the hard part, and so all I'm doing now is I'm working with measuring, and so I'm going to put the point of my compass here, see how far it is to the T there, and then measure that same distance here. Then I do it with the green. Put the point of my compass here, see how far it is, copy that distance over here. Point of my compass here, see how far away the T is, make a matching line over here. All right, once you have those marks, you make the top of your T, join it down here to the bottom of your T. And what that should look like, ideally, what it should look like is it reflected and then re-reflected. And ultimately then was just a translation. Okay, now, the question then says, how far did that translate? Well, if you think about this for a second, would you agree, would you agree that, let's just work on my bold line that was drawn correctly. This line here is supposed to be the same distance as this. Okay, the way we measured it, it's supposed to be the same. So would you also agree that this distance here is supposed to be the same as that distance? Okay, so when it says how far did this T move to get to there, well, whatever this measurement is, and this measurement, and then doubled because I did it over here on both those sides. So whatever the distance between the two lines is, and this is what I'm going to write for an answer, the translation is always going to be double the distance between the lines. So if you know how far it is between your two lines, you'll know that your translation actually ends up being double that. Okay, so if you look at this F, if I were going to reflect this F over L and then over M, and so it's going to reflect over parallel lines, the resulting image should actually be a translation. Okay, it's going to look like a translation. And how far? Well, if the distance between the lines is 7 units, after I get done reflecting it, it's going to be double that. So this is actually a translation. And it's going to end up being 14 units. All right, so that's the first type of problem, is just reflecting over parallel lines. That's the first type. Let's move on. The next thing I might do is reflect over intersecting lines. So if you look at this example, here is our pre-image. I'm going to reflect it over L, so then it looks like this gray triangle. And then I'm going to take my gray triangle and reflect it over M, and I land over here. And then what you should notice is ultimately after a reflection followed by a reflection, it's actually just a rotation. Okay, so that's what we're going to fill in here. It's a rotation. Now my next question is, how far did it rotate? Because you can see right here I told you that this was 80. Well, let's look at the next slide. On this one, you can see that in this particular example, this is my pre-image right here. And so if I was going to rotate this, this distance here, this rotation angle, should be the same as this rotation angle. And that's why it lands over here as a nice reflection. So 1 and 2 are the same. But then when you take that and reflect it over to that, that's going to make 3 and 4 be the same. So what's this total rotation angle then? Well, if this is 60 right here, vertical angles are congruent, this is 60. 2 and 3 add up to 60. But remember that this is the same as this, and this is the same as this. So 1 and 4 would add up to another 60. It's always going to be double. So if that angle that it's working through is a 60, then it's going to end up rotating 120 degrees. It will always be double of that angle. All right, let's try one of these rotations. Well, really a reflection and then another reflection that looks like a rotation. I'm going to need my note card again, and I'm going to do this all in one color. Hopefully you can follow along. I'm going to start off, and I'm going to look at the 3 key points that I need to reflect. Those are my 3 key points. So then I'm going to take my note card, maybe. I'm going to line it up here. And I'm going to try to line it up with my point and with line L. I'm supposed to be reflecting over line L and trying to force that to stay 90 degrees. So right there-ish, and then I know that I'm going to want to point somewhere like right here. When I say a point, what I really want is a line. That's terrible, sorry. It's just, this thing just does not working for me. I apologize. You can use your note card because you can do it. I'm going to eyeball it because I'm the teacher and I can eyeball it correctly. Maybe. We'll see. Okay, so here's a point, and what I'm trying to do is eyeball a 90-degree right here. I would rather you not eyeball it. Okay, but I'm going to make it extra long when I do that. So I'm putting in these 90s. These should all be parallel to one another if you do it right. They're all creating perpendiculars with the line of reflection. Then I'm going to take my compass, or maybe if you want to use a ruler and measure, but I'm going to say from here, this is that far, so then I put an equal mark on the other side. From the line of reflection, this point is here, I'm going to put a mark on the other side. From the line of reflection, this is that far away, I'm going to make it a matching distance far away. And what I end up with is a new triangle that has been reflected. There it is. Hopefully yours looks similar. Now what I'm going to do is I'm going to take that and I'm going to reflect it over line M. Okay, so I'm going to change my colors up a little bit here to help keep this from getting crazy. But I'm going to use my note card to make sure that this point is perpendicular to this line, and then keep it on going. Now mine happens to kind of line up, but since I freehanded it, I don't know that that's actually accurate. Does yours line up like that, where those are the same? And then this one would be out here somewhere. Okay, sometimes we do that where those line up just perfectly like that. Now I'm going to take my compass or my ruler and I'm going to measure so that when it reflects, it's the same distance on the other side. So from right here, I'm going to mark this and put a matching mark. And then I'm also going to mark this one and put its matching mark. Point of the compass here, mark off how that distance, put the matching distance. Okay, so then your resulting triangle looks something like this-ish. Okay, of course you know better, you know that this should be more accurate on yours than what mine is. Mine is pretty iffy here because I'm just eyeballing stuff, but yours should be accurate with your construction tools. All right, let's keep moving. All right, the last composition of isometry that we're going to do is a glide reflection. And this is a little bit easier because I'm not going to have to worry about my note card because I'm going to do everything on a coordinate plane, and everything is nice and perpendicular on a coordinate plane. The idea is that you are going to glide and then reflect. So in this example, here's my pre-image. I'm going to glide and then reflect over. That's how this works. All right, we're going to do it on this coordinate plane. And the way that the notation works, this is a reflection over x equals 0 of the translation, 0 units right and 5 units down of the triangle. So remember, you do it kind of backwards. You're going to start with your glide, you're going to do this first, and then you're going to come back and reflect. So it looks like, based on this translation, it does not move left or right, but it's going to go down 5. So I'm going to take every one of my points, and I'm going to take them down 5. So this one right here goes 1, 2, 3, 4, 5. There's my new E. We'd call that E prime. X goes down 5. 1, 2, 3, 4, 5. Right here, that's X prime. T goes down 1, 2, 3, 4, 5. T prime. So my new triangle looks like this. You don't have to use a straight edge for that. You can just eyeball it. Okay, that's the glide. Now I'm ready for the reflection. Now the reflection is over the x equals 0 line. You're going to have to remember your Hooyvux for this. X equals, so that's x is a vertical line, so I want a vertical line at 0. I'm going to go ahead and draw that in. That's what I'm reflecting over. So the reflecting in a coordinate plane is a lot easier because it's already got the horizontal, or the perpendicular line right there. I'm 1 unit away, I'm going to go 1 unit away. So that's my new E, and we'd call that E double prime. Okay, this point here is 1, 2 units off my line, so I'm going to go 1, 2 units off the line. That's my new X. Call it X double prime. T is 1, 2, 3, 4, 5 points, so go 1, 2, 3, 4, 5 points. T double prime. And that is your image. That would be your resulting image. All right, let's try one more of these. This one is a reflection of y equals 3 after the translation 2 units right. no units up or down. Okay, so I'm going to be moving it right 2 to begin with. So every point goes right 2. So 1, 2, 1, 2, 1, 2. So this is my first result after the glide. Now I'm going to do my reflection. This is over y equals 3. Again, thinking Hoivux. A y equals is going to be a horizontal line at 3. So that's right here. I'm going to reflect over this line. So I'm going to take my green triangle and see how far from that line it is. So right there, it's 1 unit. Go 1 unit. There's my new point. This is 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. All right, got my resulting figure right here. And to label that, let's look at what we've got. P went from here to here and then up here. So this is P double prime. Q went here and then reflected to here. So this is Q double prime. And R would be right here, R double prime. All right, so your homework today is a worksheet. Hopefully you can get through that. Good luck.